In this video, I would like to revisit the current design of our Java-like string in C++. And just a reminder that we went from initial version where we were using some sort of prototype using constant string. Then we decided to rely on the functionality of the string view from C++ standard library to provide very convenient operations that we can use in our implementation of Java-like string. Then we added assignment operator to our string, and we also added a few more operations in the last version. And today I would like to discuss one more interesting aspect of using this class Java-like string in C++, which involves continuation of our discussion about deep copy versus shallow copy, and the need for yet another constructor in our class. So to get started, I'm just going to open this project. And this is our main function that we primarily used for testing of our string concept. And as you recall, our latest tests went on to operations such as replace, comparisons, checks for equality, and finding substrings and other types of operations. So primarily we focused on functional operations that exist in Java string, and so we try to demonstrate how we can build very similar object that uses class string. So I would like to think about a function that requires copying of our strings. In fact, let's take a look at our copy constructor. So we have a copy constructor. Let me just bring in all the source files that we have here. So this is our header file, and this is our implementation file for the string, and this is our copy constructor. So I'd like to be able to trace where we call copy constructor. So most C++ compilers that are popular today using or providing this macro at compile time __ function in all uppercase that we can use to display the name of the function that is being executed. And I say copy function. So let's just I will keep this debugging line in our copy constructor, and I simply want to build and run to see when we can observe that we invoke this copy constructor. So you can see that we do have a trace of the copy constructor being invoked during the execution of our program. So okay, so this trace line works whenever the copy constructor is invoked. Then I would like to try something else. It's possible that I could create a function in this, let's do this in our testing module right above the main function. A function, for instance, such as select string. So for example, the idea of selecting a string is that we could have a function named select string, and this will be the declaration of this function prototype right here. that I may try to decide that in my code, in my application, I would like to choose between two strings. So I can provide like one string and another string to this function. And depending on other conditions in my application, I may try different select modes. In one case, I may select left. In another case, I may select right. In another case, I can concatenate them. So I'm thinking about, some possibilities here, and let's add this enumeration into this program. So for instance, the selection modes right here could be one of these enumerated types, which is the set of constant in our code. So select left, right, left and right, or right and left. Okay, let's think about a possible implementation for this function. And since I have the prototype for this function, I'll just try to work on the implementation down here. So this is the possible structure for this function select string. So it takes references to two of the strings, and based on select mode, we make a switch. And based on the modes, left, right, and so forth, I try to decide that, okay, the user wants left or right, or they want to concatenate left and right, or right and left. So I also predict that there could be, unspecified select modes. In that case, I'm constructing an error string with this message that this is bad select mode, and here I'm returning this the copy of this error string. So now let's think about possible testing cases for this string, for this function select string, and let's try this. Okay, so we'll try some cases. So here I call this function named select string, and I'm using these select modes that I predefined in that enumeration on top of my file. So I'm trying to say select left, right, and then left, right, or right, left for concatenation of the string. And finally, I try something like a garbage value for the select mode, which is none of these predefined modes. And in that case, I'm expecting, of course, to see this error message being printed. So these are the cases right here. So let's just print this maybe. Test output like this with the new line, and we'll print these various cases. So I'm just going to save this and build it, and when I run it, you can see that we have once we compile the code, we begin to print the cases for our string selections, starting from here, and we call it with left and right, and again I constantly pass in strings left, right, the same strings, but the selection modes are different, so I use different combinations from assembling the result from the left and right, whichever is the case. And observe that I begin to call copy constructor. Well, what happens here is that when we start to deliver the resulting object as a return value from our select string, of course, we have a need to construct a copy of an existing string. So that's obvious that compiler chooses to create a copy, like invoke copy constructor, to take this as a prototype and return brand new copy. So that's not a surprise. So in case of the left, when we produce the left result, when we request to make a copy of the left, copy constructor is involved, and we return the left. Similarly, we call copy constructor before returning the right. Now, when we call concatenation, concatenation is already using constructor at the very end of its implementation. So, for example, if we search for our concatenation right here, we use specific constructor as part of our string design, and we know that this constructor is designed to construct a string which dynamically holds a block of memory allocated dynamically right here, right? So it will construct the string which will guard the block of dynamically allocated characters, and when this string is disrupted, the characters will be properly deallocated to prevent memory leaks. So we did this work a while ago, and so you see that at this stage, because we're just at the return statement, so we return a new version of the string. Compiler knows which constructor we would like to use. And you see, when we're trying something like this, like concatenate and concatenate, that uses that constructor, copy constructor is never called again to basically get the result of concatenation, and it does not involve another constructor to construct another string. So the copying is not involved here because we know that specific constructors are used. So far, this story of which constructors are invoked in all of these cases makes sense because that's the best course of action to manufacture the string which is a result of the selection between left and right or a combination of both. However, notice again that when I constructed a local object in this function select string, and I call it error string, and I just give it initial value, and I decide to return it in the condition when there was some sort of unpredictable select mode. Look, this error string, of course, is passed to our main testing program here, and we print the result, and this is all expected. We were expecting this to happen because we passed unpredictable unknown select mode to this function. However, notice that the copy constructor was invoked. So, in order to create the string and pass the string to the caller, compiler has no choice but to decide to invoke specific constructor to construct this local string. And then when this string has to be used as a prototype to pass it to the caller, compiler properly invokes copy constructor. At the same time, this doesn't make much sense. Perhaps what we would like to do is to be able to simply pass this very object directly back to the caller. Wouldn't it be nice if we somehow could jump the boundaries of this function, and despite the fact that this error string is a local variable that exists in scope of this select string function that we used to construct necessary strings, wouldn't it be nice if this string, without the need to use copy constructor, if it could be just passed as the result from this call? In other words, we would like to avoid making deep copy. So this is partially possible with the use of the move constructor, which we're going to discuss right now.